Welcome students. So yesterday at the end of the session I was talking about Wheatstone's network, and at the end I said Wheatstone's network finds many application, and we already come across solving one problem using the balanced Wheatstone's network, correct? Today let us begin the session with one more application of a Wheatstone's network, that is an instrument called meter bridge. You can say in a simple words, meter bridge is a practical form of Wheatstone's network. I said meter bridge is a practical form of Wheatstone's network. Whatever the network you are seeing at this corner of the paper, it is obviously a Wheatstone's network. We already discussed it yesterday, correct? So meter bridge is a practical form of a Wheatstone's network. I said this is a Wheatstone's network for our reference. What is the use of this meter bridge? For a many purpose, this meter bridge can be used. Using meter bridge, you can, or it can be used to determine the resistance of a given conductor. Using a device called meter bridge, or using the instrument called meter bridge. Of course, nowadays it may be an outdated device because we have a latest device called ohm meter. Other day I told you, using just by connecting the two ends of the given material to the two ends of the ohm meter, you have a device called multimeter which is used for a multi-purpose. Yeah, that is different thing. So I said using meter bridge you can determine the resistance of a given conductor. How, that is a point of our discussion today, and how we would like to know how you can say that meter bridge is a practical form of a Wheatstone's network. That also we would like to know. You know, each and every instrument has got some basic principle on which it works. The basic principle behind the working of a meter bridge is a balanced condition of Wheatstone's network. The basic principle on which the meter bridge works is a balanced condition of Wheatstone's network. This can be a possible one more question. Mention the principle of a meter bridge. Meter bridge works on the principle of balanced condition of Wheatstone's network. What is a balanced condition of Wheatstone network? Network is said to be balanced. For your information, just recall, network is said to be balanced if current flowing through the galvanometer is 0, correct? Or the ratio of the edges and arms of the resistor should be equal. P by Q is equal to R by S. This is a balanced condition of Wheatstone network. That is a basic principle behind the working of a meter bridge. Okay, fine. I started with meter bridge saying that it is a practical form of a Wheatstone's network, and I said meter bridge is a device used to determine the resistance of a given conductor. That is okay. We'll try to understand what do you mean by that. And even I mentioned the basic principle behind the working of a meter bridge as a balanced condition of a Wheatstone network. That is nothing but current flowing through the galvanometer is 0, or the ratio of the edges and arms of the resistors are equal. Next question is, what is this meter bridge? Let me describe. Means I am going through the description of the meter bridge, what exactly it contains. So listen carefully. This year in physics practicals you are having a two experiments which are performed using this device called meter bridge, using this instrument called meter bridge. So listen carefully, helpful lot for your practical classes also. I'll start with the description. This meter bridge consists of a rectangular shape wooden frame. It is consisting of a rectangular shape wooden frame. On this wooden frame, at the two ends, there is a L-shaped metal strips. I said there is a L-shaped metal strips. This is a one metal strip at one end, and here there is a one more metal strip at the other end. These metal strips have a negligible resistance. On either end of this instrument, I said it is consisting of one wooden frame, a rectangular shaped wooden frame. On either end there is a two L-shaped metal strips. These metal strips have a negligible resistance. They don't have a resistance. Just like your copper wire, they have a resistance but negligible. Conductor, no, obviously they will have some resistance, but it is negligible, I said. And these dots which I am marking represents the terminals which are there in the L-shaped metal strip used for a connection. On this wooden frame again, between the two L-shaped metal strips, there is a one more metal strip. There is one gap between this L-shaped metal strip and this metal strip, and here there is one gap between this metal strip and L-shaped metal strip. Technically, with respect to you, how you are facing the camera or a paper, I can say this is a left gap and this is a right gap of the meter pitch. Remember the word left gap and right gap. And even on this metal strip also, there are terminals for electrical connection. Then there is a uniform wire. There is a uniform wire of length 1 meter fixed between these two metal strips. I can say a wire of uniform cross-sectional area fixed between these two metal strips. For your reference, I will name this point terminal as A and this terminal as C for our convenience. And that wire which is fixed between A and C of length 1 meter, I said, listen to this carefully, length 1 meter or 100 centimeter. It is a wire not made up of a single conductor like copper or aluminium. It is an alloy. Alloys like nichrome, you heard about them, no? Nichrome, constantine, manganese, such wires are preferred because they have a high resistivity and low alpha. What is the meaning of high resistivity? When resistivity is very high, small length of the wire is sufficient to have a resistance. And when resistivity is very, I mean to say a TCR, low alpha means temperature coefficient of resistance material is low, indicating that its resistance do not vary much with the temperature. For your kind information, this nichrome or a constantine or a manganese, an alloy which is fixed between A and C, whose length is 1 meter, can have a resistance nearly around 100 ohm. Only 1 meter length of this nichrome can have a resistance of 100 ohm. That is from A to C. Of course, there is 1 meter scale also just below this wire to measure the length. There is 1 meter scale fixed on the wooden frame. This is meter bridge. Nothing special you can make out. Let us quickly describe once. It consisting of a rectangular shaped wooden frame. On the rectangular shaped wooden frame, on either end there is a two L-shaped metal strips. And between the two L-shaped metal strip, there is a one more metal strip leaving the two gap. One is a left gap and other one is a right gap. And there are terminals for electrical connections. And between the terminal A and C, there is a wire of uniform cross-sectional area is fixed. Its length is 1 meter and this wire is an alloy. It can be a nichrome or a manganese or a constantine. You know the idea behind why this alloys are used, because they have a high resistivity and low alpha. Their small length is enough to have a more resistance. Low alpha indicating that this resistance do not vary much with the temperature. This is meter bridge. Next common question is, if this is a meter bridge, where there is a comparison with this Wheatstone's network? Because I told you, no, meter bridge is a practical form of a Wheatstone network. There is no comparison at all. So you need a patience. You will get a complete comparison when I use this meter bridge for an experiment. That experiment which I am going to perform is to determine the resistance of a given conductor. Okay, let me start with the connections to perform the experiment. So, conductor whose resistance has to be determined, you are supposed to connect across the left gap of the meter bridge. I will represent that conductor whose resistance you are supposed to find out by the symbol P, by the notation P. For your information, this is not known to us, unknown. It is unknown. And using a connecting wires, copper wire, we are connecting the two ends of that conductor to the left gap of a meter bridge. I think you understood. This is a conductor whose resistance has to be found. I have taken the resistance as P, which is not known to us. It is connected across the left gap of a meter bridge. A resistance box in which you can keep some standard resistance has been connected across the right gap of the meter bridge. Even the resistance box also has got two terminals. Take a wire from the two terminals of the resistance box, connect across the right gap. And during the experiment, you're going to keep some resistance in the resistance box that you will be knowing. So I can say it is known to you. P is unknown. It is a conductor whose resistance has to be found. Q is known to us. And resistance box, other day I have showed you the picture. I'm having a real resistance box with me. I'll just show it to you in front of your camera. Try to see it. Try to understand this. You might have seen this resistance box. See, these are the two terminals of the resistance box. There is no positive negative terminal in this resistance box. Two terminals. And here there are knobs. Can you see this knob? Here it is mentioned. It is a multiplication of a 10 ohm. This is a multiplication of a 1 ohm. There is a multiplication of one more is there. Multiplication of 0.1 ohm. So I'll turn it. See, now I think you are able to see it. It is a multiplication of a 0.1 ohm. Yeah, this is a multiplication of a 1 ohm. And can you see there is a knob and it is having an indicator. By turning the knob, you can keep it at 1, 2, 3, just like a regulator in a fan. Suppose if I keep all the knobs at 0, these are the two terminals for the connection. I said these two terminals are connected across the right gap. All the knobs at 0. And if I keep this knob at 1 into 1 ohm is kept. If I keep at 5 into 1, 5 ohm is kept. If I keep 5 in this multiplication of 1 and another 1 in multiplication of a 10, it will be 10 into 1, 10 plus 5, 15 ohm, like that. This is a standard resistance box. I think you understood. See, this is a standard resistance box. Okay. So that resistance box is connected across the right gap of a meter bridge. Conductor is connected to left gap and standard resistance box is connected to the right gap. Then the next connection is from this middle terminal, from this particular terminal, take one copper wire and that copper wire should be connected to the galvanometer. Yesterday only I have seen a galvanometer. The galvanometer has got a two terminal. One connection was taken from this point and it is given to connection is given to the galvanometer, and other end of the galvanometer is connected to the other end. From the other end of the galvanometer, take one wire and that is connected to a pointer, or you can say sliding contact, or we also call it as a joystick key. Pointer or a sliding contact or joystick key. The joystick key in a short term we call it as a jockey. Pointer or a sliding contact or a joystick key. Joystick key, I said, in a short form we call it as a jockey. See, it is somewhat like this structure. This structure where it is a conductor. One end of the conductor, it is having a terminal where wire can be fixed, and other end is a sharp end, only almost slightly smaller than this size of the sketch pen. One end, it is having a terminal where I can turn that and keep the wire and make it tight, and other end is a sharp end that is shown here. I hope you are able to follow. Okay. So, and covering that, there is an insulation cover, means insulation coating, where you can hold this joystick key, jockey or a pointer or a sliding contact comfortably without getting any shock. Only this edge and this terminal is can be seen outside, metallic one. Remaining portion of this sliding contact is covered by an insulator, where you can hold this sliding contact in your hand comfortably when you're performing an experiment. You got it what I said? Okay. Then the last part, from this A, take a connection. Again, copper wires are used for a connection. It is connected to the positive terminal of the cell, and negative terminal of the cell is connected to C. Of course, you can include one key, not required also. Directly connect a negative terminal to the C. I hope you follow. This is a circuit connection. I'll repeat. Start with unknown resistor whose resistance has to be found is connected across the left gap of a meter bridge. Resistance box where we are going to keep some resistance is connected across the right gap. And from this terminal, a connection is given to the one terminal in the galvanometer, and other end the connection is given to the pointer or a sliding contact or a jockey. Again, from A, there is a connection given to the positive terminal of the cell, and negative terminal of the cell is connected to C. So don't you think that when this is A, even this point is also A only, because they are on the same metal strip. These metal strips are having a negligible resistance, means these 2 points are at same potential. When this is A, even this is also A. When this is C, can I say even this point is also at C? Because they are also on the same metal strip. When this is C, can I call this as C? Obviously not, because there is a resistance box. When this is A, can I call this as A? No, there is a resistance. I hope you are able to follow. Now if I name this point as B, can I say this is also B? Even this is also B only, because all those terminals are on the same metallic strip. Obviously all are same point B only. Now at least you get 75% of the comparison with the Wheatstone's network. See how? A to B, there is P connected. See? A to B, who is connected? P. This is over, correct? Then, that part is over. Then, B to C, there is a resistance box where there is some resistance Q is there. B to C, there is some resistance Q is there. This is over, this is also over. I hope you are able to follow. A to B, there is P. B to C, there is Q. Those two are over. Then from A to C, there is a cell. See, A to C, there is cell. This is also over. I hope you are able to follow. Then from B to the one terminal of the galvanometer, that is also over. B to the one terminal of the galvanometer is also over. Any doubt up till here? Fine. I don't think you have any doubt. I think it is clear to you. Okay, now remaining portion left is from A to D, C to D, and galvanometer to D. Only those things has to be understood. That you will get only when you complete the experiment. We just did the connections, right? We just did the connections. Now you have to perform an experiment. What is the aim of the experiment? To determine the resistance of a given conductor. That is taken as P here, which is not known to us. Okay. Now let us go through the experiment. Experiment is very simple. What you need to do is, you keep some resistance in the resistance box Q. I showed you that time how to keep a resistance box Q. Let us say I have kept around 10 ohm. 10 ohm resistance was kept. As an example, I kept resistance in the resistance box Q as 10 ohm. Then, you know how will be the galvanometer, right? Display of a galvanometer yesterday I have seen. In a galvanometer, 0 reading will be at the center, and there will be a 30 divisions on either side of the 0 on the scale, and the pointer will be reading 0 in the beginning when there is no current flowing through the galvanometer. What you need to do is, if I say that this is your pointer or a sliding contact where this end is connected to the galvanometer and other end is a sharp end, you take a sliding contact or a jockey, switch on the battery, that is important, switch on the battery, all the connections have to keep in contact with the wire fixed between A and C near NDA. When you keep a jockey in contact with the wire fixed between A and C near end A, pointer in the galvanometer will show a deflection to one side. Then again take out a jockey which was in contact with the wire. Just remove the jockey from the contact. Again the deflection will become 0. Now you keep a jockey in contact with the wire fixed between A and C near end C. You should keep the jockey in contact with the wire. So when you keep a jockey in contact with the wire near end C, the deflection shown by the galvanometer should be in opposite direction. I hope you are able to follow. When you keep a jockey in contact with the wire near end A, deflection shown by the galvanometer is to the one side, and remove the jockey, deflection will become 0. Again, when you keep a jockey in contact with the wire near end A, deflection in the galvanometer is one side of the 0. Pointer in the galvanometer will show deflection to one side of the 0. And when you keep a jockey in contact with the wire at other end, that is near end C, the deflection is to the other side of the 0, indicating that connections are proper. What is proper? Connections. Now again come back. Keep the jockey in contact with the wire near end A. Again, it is showing a deflection of 30. Now keep on sliding, keep on moving the pointer or a jockey in contact with the wire towards end C. Slowly, you can lift and keep. See, once you keep it here, next you remove, deflection becomes 0, again keep it here, next point. Like this you can try. I think you are able to follow. So what do you expect? What do you expect? Based on your common sense. Obviously, deflection should keep on decreasing. Deflection read by the galvanometer should keep on decreasing, because you know that when you keep it at another end, deflection is opposite side, means now when you keep on sliding the pointer or a sliding contact in contact with the wire towards the other end C, deflection read by the galvanometer goes on decreases. Don't you think that when you keep a sliding contact in contact with the wire at some point, let us say here D, deflection will become 0? It's a very much common sense. When you keep a sliding contact at one position of the sliding contact in contact with the wire, deflection in the galvanometer should become 0. Let us name that point as D. Of course, we know that if you remove the sliding contact away from the contact, deflection will be 0 only. But I am expecting a deflection in the galvanometer 0, even though the sliding contact is in contact with this wire, that alloy. Let us say when it is kept at D, deflection read by the galvanometer is 0. What do you mean by when the wire is kept, when the sliding contact is kept at D, deflection read by the galvanometer is 0? Current flowing through the galvanometer is 0. Current through the galvanometer is 0. What do you mean by current through the galvanometer is 0? Network is balanced. No. So once you locate that position where the deflection read by the galvanometer is 0, you need to measure that length from A, from the left hand side. What is the total length of the wire? 1 meter. You measure this length. This length is called as balancing length. What is that length is called as? Balancing length. We denote it by the symbol L, and it is expressed in meters. It is denoted by L. You know why it is called as balancing length? Because at that length only the network was balanced. We found. Assume that the balancing length was around 55 centimeter. 55 centimeter means how much meter? 0.55 meter. This is L. What is the remaining length then? Obviously 1 minus L, right? Because the total length is 1 meter. I am talking in terms of meter. Total length is 1 meter. If this is 0.55 meter, remaining is 1 minus L. That we are not interested. I believe you understood the discussion. Now coming to the point. How to calculate resistance? Very simple. Our aim is to calculate P, right? P is given by the formula QL by 1 minus L. What is L stands for? Balancing length. You know L, you know Q, substitute, you will get the answer for P. That is how we find. Now the question is why we are using this formula, that's all. I gave a formula directly, right? But I will explain why we are using that formula. Very simple explanation. Now before I explain it, shall I give a 100% comparison with the meter bridge? I mean Wheatstone network? See, 100% comparison now when you complete the experiment. A to D there is R. See here. From A to D there is an alloy of length L. Don't you think it has got some resistance? Yes. D to C there is an alloy of length 1 minus L. Don't you think it has got some resistance? Yes. The resistance of this alloy of length L is R. That is this one. The resistance of this part of the alloy of length 1 minus L is S. That is this one. And from the galvanometer to the D, galvanometer D, connection is already there. Galvanometer to this D. I think you got it. Okay, now coming to the last point, why this formula? When you keep the sliding contact in contact with the wire near end D, at point D, since network is balanced, don't you think that I have to use a formula P by Q is equal to R by S? Since network is balanced, current flowing through the galvanometer is 0. So P is unknown, Q is known. That is equal to, don't you think that R is resistance of the wire? R is a resistance of the wire of length L. Correct? This alloy of length L has got resistance, that is R, divided by what is S? It is obviously resistance of the wire of length, 1 minus L. Don't you think that both the made up of same material? Remember, P is unknown, Q is known to us. We already know what value of Q we have kept. Resistance of the wire of length L can be replaced as rho L by A. R is equal to rho L by A. Resistance of the wire of length 1 minus L is rho into 1 minus L by A. In both numerator and denominator, rho is same because it is the same wire, same material from A to C. A to D and D to C are same material. Even A is also same because it is a uniform wire, I said in the beginning when I gave a description. That means, can I cancel rho by A here? What you are left out with? P by Q is equal to L by 1 into L by 1 minus L. This is a formula. I believe you understood the discussion. That's why this formula was directly given here. P is equal to QL by 1. This is the explanation. It is purely using the balancing condition of Wheatstone's network. Is it clear? I think you followed this. Yeah. See, if you want this explanation, you can copy in your study material. It may be directly given there. If you want to copy these steps, you can copy it. Okay, before you copy, one more simple question I'll ask with you. You please try to answer this. What if I get in your meter bridge, if I get balancing length exactly at the midpoint? Exactly at the midpoint means 50 centimeter. That is 0.5 meter. If L is 0.5 meter, what is 1 minus L? 0.5 meter only, no? L is 0.5 means and 1 minus L is also 0.5, which implies, don't you think that P is equal to Q that time? If you use the formula, P by Q is equal to L by 1 minus L, P by Q is equal to L is 0.5, 1 minus 0.5 is also 0.5, it will get cancelled, which implies P is equal to Q. Means unknown resistance is equal to resistance kept in the resistance box if the balancing length is 50 centimeter. So always when you perform this experiment in the meter bridge, we follow one rule. One rule we follow. That is, you have to adjust Q. P cannot be adjusted because P is fixed, right? You have to adjust Q such that balancing length should be between 40 centimeter to 60 centimeter. For a simplicity here, I might have said keep Q and find a balancing length. But in reality, when you're performing the experiment with the meter bridge, you have to follow one rule. The rule is you have to keep such a value of Q. You have to adjust Q value. Q is a resistance kept in the resistance box. You have to keep such a value of Q that the balancing length should be between 40 centimeter to 60 centimeter, because in such length, error will be minimum. Errors will be minimum. That is why we follow this condition when you're performing the experiment with the meter bridge. Listen to this carefully, the last point. When you perform an experiment with the meter bridge, we follow one condition. The intention behind this is, if you get a balancing line within this range, the errors will be minimum. When the and obviously readings will be accurate if you take a balancing length as 50. Means keep a sliding contact at 50 centimeter, then keep on adjusting Q till the deflection becomes 0. Keep the sliding contact in contact with the wire at 50 centimeter, then keep on adjusting Q till the balancing length till the deflection becomes 0. Then that QP will be equal to Q. That is the meaning. Understood? Please copy this information, like why you are using this formula. Copy this point. Remaining things are there in a study material. I hope you understood the discussion related to the meter bridge. Copy this from here to here. So if they ask a question, why in a meter bridge they say that balancing length has to be obtained between 40 to 60 centimeter. 40 to 60 means it is obtained by adjusting the value of Q, known resistance, just to minimize the error. Because if you get a balancing within that range, error will be minimum and readings will be accurate if you get a balancing that as exactly 50 centimeter, midpoint. That means how to achieve that? Keep the sliding contact in contact the wire at 50 centimeter, then keep on adjusting Q till the deflection in the galvanometer becomes 0. So more idea you'll get when you perform the experiment. So this is for timing, it is enough. So this is about your meter bridge, and you keep your numerical problems and AAC level 1 problems ready with you. I think you copied this. Remaining things are there. You need not copy. This you copied, right? P by Q is equal to R means resistance of the wire of length L, that is between A and D, between AD. Resistance of the wire of length 1 minus L, that is from D to C. This calculation. Okay, we'll directly tackle one problem, and this condition also you can write. The rule is that when you perform the experiment, you have to adjust Q such that the balancing length should be between 40 centimeter to 60 centimeter, because in that case the errors will be minimum when you perform the experiment. Because experiments will involve a lot of error. To minimize the error, it is better to take a balancing length between 40 to 60 centimeter. One of the question in AAC level 1, problem number 9. An unknown resistance R1 is connected in series with a resistance of 10 ohm. This combination is connected to one gap of a meter bridge, while resistance R2 is connected to the other gap. So we'll take it like this. It is a meter bridge. This is a meter bridge. So what they said is, here there is R1 connected in series with a 10 ohm. R1 is there, 10 ohm is there. And here you are having R2. Correct? They said balancing length, I'll take it as L1, balancing length L1 is found to be 50 centimeter. 50 centimeter means exactly midpoint, correct? Don't you think that when balancing length is exactly midpoint, this resistance in the left gap should be equal to resistance in the right gap? Normally we take the resistance in the left gap as P, resistance in the right gap as Q. P should be equal to Q. Or you can use the formula, I don't mind. P is equal to Q into L by 1 minus L, which implies, what is P? It is R1 plus 10, because P is nothing but effective resistance of the left gap. R1 and 10 ohm are connected in series, no. R1 plus 10 is equal to, what is Q? Q is R2, balancing length is 0.5 by 1 minus 0.5. This will get cancelled. So you will get the first equation as R1 plus 10 is equal to R2, correct? Yeah. Later what they said in the problem. Now when 10 ohm resistance is removed, that means you are going to remove 10 ohm resistance from the left gap. Now when 10 ohm resistance is removed and the balancing point shifts to 40 centimeter. Now in the new situation, I am having only R1 at the left gap and R2 at the right gap, correct? 10 ohm is removed. One more L-shaped metal strip, correct? This is the first case and this is the second case. In the second case, you are removing a 10 ohm from the left gap. When you remove 10 ohm from the left gap, if I use the same, what what is L? 0.4 divided by 1 minus L means 1 minus 0.4. No, you will get R1 is equal to R2 into 0.4 by 0.6. I think you understood the explanation. What you are asked to calculate? Value of R1. We want to know what is the value of R1. How to find the value of R1? Using this, can't you get answer for R2? This can be taken as, if I am not wrong, 6 into R1 by 4. I multiplied both numerator and denominator by 10. This will become 4 by 6. Cross multiply. 6 into R1 by 4. Don't you think that R2 will be equal to 3R1 by 2? 2 2s are 2 3s are. R2 is 3R1 by 2. Substitute in this formula. I'll write here the last step. R1 plus 10 was equal to R2, correct? Or R1 plus 10 is equal to, what is R2? They said 3 times R1 by 2. Cross multiply. 2 times R1 plus 20 is equal to 3R1. Shift to 2R1 this side, which implies R1 is equal to 20 ohm. Do you agree with me? Because 2R1 minus 2R1, 3R1 minus 2R1 is R1. R1 is nothing but 20 ohm. The answer is B. I hope you followed this. Please copy the solution. There are two parts. In the first part, R1 and 10 are connected to the left gap. In the second part, 10 ohm is removed. So just look at the, explanation given. Copy the solution. So don't take too much time. Copy as quickly as possible. So here balancing length is 40 centimeters, that is 0.4 meter. AAC level 1, AAC level 1, 9th problem I said. Finished? Yeah. I hope you completed. Yeah, refer AIC level only. This is over, right? Should be quick enough. So the last part is here. This substitution I have done it here. R1 plus 10 is R2. R2 was replaced as a 3R1 by 2. Over. So it is 20 ohm. Okay. Next you take up AAC level 3. AAC level 1, problem number 3. Problem number 3. Yeah. So you should not use a calculator for this problem. It is actually a question asked in CET 2009. The resistance of a wire at 300 Kelvin is found to be 0.3 ohm. At 300 Kelvin, it is a temperature in Kelvin, which implies I can say T1 is equal to 27 degrees Celsius minus 273 is 0.3 ohm R1. If the temperature coefficient resistance of the wire, that is alpha, is 1.5 in 10 to the power minus 3, keep in mind the temperature at which its resistance is 0.6 ohm. R1 divided by R1 into T2 minus R2 into T1, correct? Or if I interchange this alpha and denominator, R1 into T2 R1 into T2 minus R2 into T1 is equal to R2 minus R1 by alpha, correct? Or R1 by alpha plus R2 into T1, correct? Or T2 is equal to R2 minus R1 by alpha plus R2 into T1, entire thing is divided by what? R1. That's all. Now you do the substitution, you will get the answer. T2 will be equal to, what is R2? 0.3 by what is alpha? 1.5 into 10 to the power minus 3 plus what is R2? R2 is 0.6 into what is T1? 27, right? Divided by what is R1? R1 is 0.3. This T2 will be equal to 0.6 minus 0.3 is 0.3 only, right? This is obviously 1.5 is nothing but 3 by 2, and this 10 to the power minus 3 will go to the numerator as plus 3, and this is 0.6 into 27, you can multiply, right? 2, correct? 16.2 divided by 0.3. This is, I think if I am not wrong, see, without using a calculator, how to calculate this? This can be taken power 2 by this 3 and into the 2 will go to the numerator plus 16.2 divided by 0.3. Do you agree with me? This 3 will get cancelled. So what you are left out with? 200 plus 16.2 is 216.2 by 0.3 or 2162 by 3, correct? This is 3 7. This is in degree Celsius, but options are given in Kelvin. So temperature in Kelvin will be 720 plus 273. It will be surely 993 Kelvin. Please copy the solution quickly, don't waste time. It is AIC level 1 problem, question number 3. Question number 3. Yeah, I think the question is there with you. The resistance of wire at 300 Kelvin is found to be 0.3 ohm. If the temperature coefficient resistance of the wire is 1.5 in 10 to the power minus 3 per Kelvin, the temperature at which the resistance becomes 0.6 ohm is. Yeah, you're copying the solution, right? Yeah. Be quick. This is AIC level 1 problem, question number 3. Yeah, copy this substitution. Remaining things. Nine ninety three Kelvin is answer. copied, right? Okay, be quick. So answer is option C, 993 Kelvin. Okay, now listen what I'm telling you. Now you take your study material, there go to the numerical problems. There is a similar problem is there in numerical section, numerical problem. This you copied, I believe, all of you. So at least write the steps and just copy it, copy the answer. You can cross check later. Okay, and I said go to the numerical section, numerical problems. Numerical problem number 13. Okay, I will wind up that also. I said go to the numerical problems, problem number 13. It is a repetition of the same problem, but in a 5-mark session. I think you're ready. Yeah. An electric toaster uses nichrome for its heating element. When a negligibly small current passes through it, its resistance at room temperature 27 degrees centigrade is found to be 75.3. Means what I can do is I can take T1 degree Celsius as 27 degrees Celsius and corresponding resistance as R1, that is 75.3 ohm. I think you understood. When the toaster is connected to a 230 volt supply, voltage applied is 230, the current settles. That means there was a variation in the current and finally the current will become steady after a few seconds to a value of 2.68 ampere. Now it is a very much common sense at this stage that heating effect of a current. You know, current flowing through the conductor can produce a heat. Because of the heat equal to V by I, I will take the R as R2. V is 230, I is 2.68 ampere. If you do the calculation, 230 by 2.68, 230 divided by 2.68, it will come around 85.82. 85.82 ohm. That means you can clearly make out initially when the temperature was 27 degrees centigrade, resistance was 75.3. Now the resistance has actually the question of the nichrome temperature. What is the study temperature of the nichrome element? That only the question is asked, and the temperature coefficient resistance of the material is given. That means again data is same as a problem number 3 in your numerical section. That means I have to go for the same idea, correct? If I go for the same logic, so I'll repeat, you keep on responding. Okay, alpha is equal to R2 minus R1 by R1 into T2 minus R2 into T1. This I can cross multiply. R1 into T2 minus R2 into T1 is equal to R2 minus R1 by alpha, correct? Or R1 into T2 is equal to R2 minus R1 by alpha plus R2 into T1, or T2 is equal to R2 minus R1 by alpha plus R2 into T1 divided by R1. Now remaining is substitution. Same as that problem, substitution you have to do. Tell me what is R2? 85.82 minus what is R1? 75.3, correct? Divided by what is alpha given? 1.7 in 10 to the power minus 4 plus what is R2? 85.82. What is T1? 27 divided by R1, 75.3. I think you can complete the calculation. Please copy it. Do it. Problem number 13 from your numerical problem section. First copy from the top, then you do the simplification. Calculator at the end at least. Only additional step was you have to calculate resistance when the current is 2.6. That was not there. That was already given in the previous problem. Finish it fast. Yeah. Okay, this part, this part will be 6.188 into 10 to the power plus 4. So it will be just complete the calculation, okay? Yeah, you have one more digit 2. So it will be 61,882 plus 2,317.14 is equal to some value divided by 75.3. Something around 852.6. Fine. Over copied. Yeah. So again go back to the AAC level 1 problem. So this was actually a similar problem I discussed together, AAC level 1 and the 13th problem in your numerical. Problem number go to the AAC level 1. AAC level 1 problem number 7. AAC level 1 problem number 7. Okay. Listen, this is one more variety. It was asked in one of the GE paper 2008. I said AICE level 1 problem, question number 7. A 5 volt 2 ohm battery and 2 volt 1 ohm battery are connected in parallel to a resistance of 10 ohm. The current in the 10 ohm is. See, this circuit which was given to you can be redrawn like this. Just to avoid a confusion, I am redrawing it. Tell me how the cells are connected here. Here they are in series. How the cells are connected here? They are in parallel. That difference you should know. If I don't connect any load resistance or anything across B and C, they are connected in series. They are connected because it is a single branch. EMF may be different. That is different thing. Here EMF is 5 volt. Internal resistance is 2 ohm. Here EMF is 2 volt. Internal resistance is 1 ohm. Here they are in series. Current will be same throughout. But in the actual circuit they are not in series. They are in parallel. Exactly. They are in parallel because across B and C there is some resistor R connected. Across B and C there is a resistor R connected. That resistance is 10 ohm. Okay, now it is a parallel combination of a cells now. Branch series, but now they are in parallel. Now it is not a usual parallel combination what you have learnt. In the usual parallel combination what we have learnt, we have the connection like this. This is a one cell of E1 and internal resistance R1. This is another cell of EMF and internal resistance EMF E2, internal resistance R2. They are connected in parallel, means we have connected positive terminals of the cell together, negative terminals of the cell together, correct? And across that A and B we have connected a resistor. Do you agree with me? This was a parallel combination what we have learnt. And here what you notice here is, due to this cell there is a current of I1 ampere, due to this cell there is a current of I2 ampere, and together they flow as I, means both the cells are trying to send a current in the same direction. Yes or no? Positive, negative, positive, negative. That time you got, according to discussion, E equivalent by R equivalent was E1 by R1 plus E2 by R2, correct? or 1 by R equivalent was 1 by R1 plus 1 by R2, or you could have solved R equivalent as R1 R2 by R1 plus R2. Do you agree with me? This is a formula what we have already knowing under the parallel combination of a cells where the positive terminals of two cells are connected together and negative cells are connected together. But now the circuit which was given to like this, here they are connected in opposite manner. Means the first cell of EMF 5 volt try to send a current in this direction, C to B, through the external resistor. Second cell of EMF 2 volt try to send a current in opposite direction from B to C. But through the resistor, according to the first cell, current should be from C to B. According to second cell, current should be from B to C. But in a branch, you cannot have a current in both the directions. Now the question is, what is the direction of a current through a resistor? Keep in mind that when you have this circuit, it's a parallel combination only, but it is not a usual parallel combination. In the usual parallel combination, what we have learned is positive terminal of the two cells are connected together to one common point, negative terminals are connected to another common point. But here, positive of the one and negative of the other is connected to one common point, and negative of the first one and positive of the other one is connected to another common point. Now you are having confusion of direction of a current through a resistor. It is from B to C or C to B. You can blindly answer that. Direction of a current through a resistor will be as sent by the cell having a higher EMF. Direction of a current through a resistor will be as sent by the cell having a higher EMF. I hope you are able to follow. Due to the cell having a higher EMF. Who is higher EMF? This one. So positive to negative. That means one part of the answer you got. Current will be from where to where? C to D. How many options have got current as C to B? 2 options, B and C. Out of the B and D, out of the 2, one of them is a correct answer. You understood, no? Why the current through resistor is from C to B? Because when you have this connection, you have to select the direction of the current as sent by the cell having a higher EMF. Is it clear? As sent by the cell having a higher EMF, that we have to use. Any doubt? Okay, so let me proceed. Next question is, what is the amount of current? Now, when you have a combination like this, you compare with this formula. E equivalent by R equivalent will be equal to E1 by R1 minus E2 by R2. If I say this is E1 and this is E2, this is R1 and this is R2, since E1 is of higher EMF, direction of the current is sent by the cell having higher, but this cell will try to send a current in opposite direction. No, that is why instead of E1 by R1 plus E2 by R2, since this cell is trying to send a current in opposite direction, I should take it as E1 by R1 minus E2 by R2. I hope you understood this. There is a change. Instead of E1 by R1 plus E2 by R2, I have to make correction E1 by R1 minus E2 by R2. But this formula no change because there is no positive negative in the internal resistance. 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 only. So all these things you should remember. This is a change you have to make out. Highlight this. First thing is, when you have a 2 optional direction for the current, because the 2 cells are connected in a different manner, you have to select that direction of a current as sent by the cell having a higher EMF. Keep in mind. Then since one cell is sending the current in opposite direction, parallel combination formula I am using, but this should be minus E2 by R2. EMF is negative because that cell is sending current in opposite direction compared to the other cell. And there is no change in internal resistance formula. Now what is the question? Current, right? So what is the general formula for current? E equivalent by R plus R equivalent. I have to find out E equivalent. I have to find out R equivalent. Shall I find out R equivalent first? R equivalent can be given by the formula R1 R2 by R1 plus R2. No. See, 1 by R equivalent is given by this equation means, what is R1? You can say 2 ohm. 2 ohm into 1 ohm divided by 2 plus 1. What is the answer you get? 2 by 3 ohm. R1 R2 by R1 plus R2. R equivalent I got 2 by 3 ohm. Capital R I know 10 ohm. What do you want to know? E equivalent. Look at this. E equivalent by R equivalent was equal to E1 by R1 minus E2 by R2, correct? Or E equivalent is equal to E1 R2 minus E2 R1 by R1 into R2. Entire thing is multiplied by R equivalent. Do you agree with me? I cross multiplied this. Or E1 R2 minus E2 R1 by This is R equivalent is nothing but R1 R2 by R1 plus R2. No. This is R1 into R2. Can I cancel R1 into R2? So what is the formula you got for E equivalent here in this case? E1 R2 minus E2 R1 by R1 plus R2. I think you understood this. This formula you need to remember. And this formula, R equivalent formula. Substitute. What is E1? 5. What is R2? What is R2 given in the problem? 1 ohm. Minus. What is E2? 2 volt. What is R1? 2 ohm. Divided by R1 plus R2. 1 plus 2. Or 2 plus 1. This will be equal to 5 minus 4 is 1. 1 by 3. Substitute everything here. This also. I is equal to, what is E equivalent? E equivalent is 1 by 3, correct? By, what is capital R? 10 ohm. What is R equivalent? 2 by 3. Take a common denominator. 1 by 3 by, this is a, I think 32 by 3. Do you agree with me? 3 will get cancelled. 1 by 32. 1 by 32 is nearly equal to 0.03, right? 96 something. Yeah, this is answer. I think you understood this. Please copy it. So this is a change you have to remember. The change you have to remember, okay? Yeah. Normal parallel combination, it is E1 by R1 plus E2 by R2. Now when one of the cell is reversed here, it is E1 by R1 minus E2 by R2. And this formula is as it is. Then current is E equivalent by R plus R equivalent. Copy it. Quickly. Finish it fast. This is the original formula for normal parallel combination. And I told you how to select the direction of a current depending upon the cell having a higher EMF. So it is from C to B. So which option is the correct answer then? Yeah, option D. 0.03 ampere from C to B. So this is actual formula to start the problem. Then R equivalent and E equivalent I want. R equivalent is this formula and E equivalent is this formula. Please copy it. So I'll move the paper as soon as you complete copying it, okay? Yeah. Finish this part. I'll move the paper. Yeah. So R equivalent I have found out. Then I found out E equivalent. So actually directly this formula and this formula, if you remember, you can answer. R equivalent you find out, E equivalent, then you substitute in the final formula. That's all. So what I have explained the formula. That's all. Finished up fast. over, yeah. So R equivalent is 2 by 3, E equivalent is 1 by 3. Then I substitute in the formula of I is equal to E by R plus small r equivalent 1 by 3 by 10. Capital R is 10 by plus 2 by 3. Simplified, I got the answer as 1 by 32. That is 0.031 something you'll get. Yeah, not 1 exactly, 30 again, because 32 3s are 96 again, for 31 you get 0.031. Okay, now close the ASC level 1 book. We'll come back to it at the end. We'll complete the numerical section, 5 marks question from your numerical section part. So in the order, if I go, the next problem I have to solve is a problem number 17. I think you completed. Yeah, quickly finish it up. Over. Okay, problem number 17. It was a homework given yesterday. I think you have tried the problem. I believe you have tried the problem, correct? Yeah. So we'll have a quick discussion over the answer. You know, two identical cells either in series or in parallel combination gives same current of 0.5 ampere through an external resistance of 4 ohm. Find the EMF and internal resistance of a cell. See, if I take a n identical cells, that formula, n identical cells connected in series, later connected in parallel. You know, here the formula is I is equal to NE by R plus NR. Here the formula is I is equal to NE by NR plus NR. This formula I'll use directly. You're asked to find out the EMF and internal resistance of each cell. That's all. You have to find out E and R, where they're given a current and the number of cells in the problem is 2. How many cells are given? 2 identical cells. So in the first case, I is 0.5, N is 2, E by capital R is 4 plus N is 2 into small r. If I do the cross multiplication, 4 into 0.5 is nothing but 4 by 2. It is 2 plus R is equal to 2E, correct? One equation with the two unknowns. Proceed here. What is the current here? Again, same current they said 0.5 ampere. Isn't it? Same current is at 0.5 ampere. 2 times EMF is E only. Resistance is, N is again 2 and capital R is again 4 plus N is, sorry, this is not NR. Mistake. NR in plus small r. Don't use NR. NR plus small r. You can cross check the formula I have explained in detail. Small r is obviously they have given. They have not given. It is small r only. Cross multiply. What do you get? It is 4 plus 0.5 r is equal to 2e. Do you agree with me? Let this be equation 1. Let this be equation 2. Just to do 1 minus 2 or 2 minus 1. If you do 1 minus 2, 2 minus 4 minus 2, r minus 0.5, 0.5 r, correct? 2e minus 2e, 0. Do you agree with me? Which implies 0.5 r is equal to 2, or r is equal to how much? 4 ohm, correct? When r is equal to 4 ohm, substitute here. Substitute r is equal to 4 ohm in equation 1. When I substitute r is equal to 4 ohm, 2 plus 4 is equal to 2e, correct? Or 6 is equal to 2e, which implies e is equal to how much? 3 volt over. Copy this. If it is not completed, copy it as it is. So r is 4 ohm, e is 3 volt. Finished? Okay. over yeah. We'll go on to the problem number 18. 17th is over, 18th now. Two cells of EMF 2 volt and 4 volt and internal resistance 1 ohm and 2 ohm respectively are connected in parallel so as to send a current in the same direction through an external resistance of 10 ohm. Find the potential difference across 10 ohm resistor. See, two cells, one is of EMF, they said 2 volt and its internal resistance was given as 1 ohm, right? And another cell is of EMF, I think you're listening, another cell is of EMF 4 volt and its internal resistance 1 ohm. They are connected in parallel so as to send a current through the external resistance of 10 ohm in the same direction. That means they should be connected such a way that the positive terminal of the one should be connected to the positive terminal of the other and the negative terminal of the one should be connected to the negative terminal of the other. That is the meaning of they are connected in parallel such a way that they will send a current in a same direction through an external resistor. This is an external resistor. So you have solved one AIC level 1 problem. There one cell was sending current in one direction, other cell was sending current in other direction. That is also parallel combination when the resistor is there. But one was sending the current through a resistor in one direction, other was sending current in opposite direction. But here both the cell has to send a current through a 10 ohm resistor in the same direction, means they should be connected like this. They should be connected like this. That is the meaning. I think you understood. Of course, this resistor can be connected here also between A and B. What you are asked to calculate? Find the potential drop across the resistor. The potential drop across the resistor is given by the formula V is equal to I into R. That means I have to find out I. Can I say I is current is in this direction? Current I will be in this direction. And surely that I is because of I1 and I2. Here I1 and here I2. Do you agree with me? Due to the two cells. Okay, now there are two different methods. One is a normal method of parallel combination and other one is your KVL you can use and find out. Let me explain one simplest method, direct method. After that I will explain in terms of KVL also. So first of all I need a current. Current can be given by the formula E equivalent by R plus R equivalent. Correct? So here E equivalent, if I am not wrong, is given by the formula E1 into R2 plus E2 into R1 by R1 plus R2. In that AIC level problem this was minus. No, why it was minus? Because other cell was reversed. What is the formula for R equivalent? You can refer R1 R2 by R1 plus R2. Same formula. Over. Find out E equivalent. First we'll find out E equivalent. What is E1? What is E1? 2. I will take up this as E1, this as E2, this as R1, small r1. I hope you are able to follow. This is E1, R1, E2, R2. E1 is 2, R2 is 2, E2 is 4, R1 is 1 by R1 plus R2, 1 plus 2. You will get 2 to the 4 plus 4 by 3. You will get 8 by 3 volt. Do you agree with me? EMF I got. Next one is R equivalent. How to find out R equivalent? R1, R2. R1 is 1 ohm. R2 is 2 ohm. 1 plus 2. What is the answer you get? 2 by 3 ohm. Substitute here. I equal to E equivalent is 8 by 3. 10 plus what is R equivalent? 2 by 3. Correct? You will get 8 by 3 divided by 32 by 3. 3 will get cancelled, so you will get I is equal to 8 by 32 is nothing but 1 by 4 ampere. Correct? 0.25 ampere. Coming to the main question, V is equal to I into R. V is equal to what is I? 1 by 4. Correct? What is R? 10 ohm. So it is equal to 2.5 volt. This is one method. Please copy this method. I will explain the one more method, that is using KVL. Copy the circuit diagram fast, don't waste time. Copy the circuit diagram, everything. Then copy the formula, that is using a parallel combination of the cells formula. Circuit diagram you copied, expression for a current you copied, I is equal to E equivalent by R plus small r equivalent. Then the formula for E equivalent here, this step, E equivalent is E1 R2 plus E2 R1, and substitution was done. Substitution was done for E equivalent. Then we were solving for R equivalent. Over. So you will get E equivalent as 8 by 3 volt, R equivalent as 2 by 3 ohm. I have the formula, substitution is done. For I first, I is equal to this formula, do the substitution, copy it quickly. This is actually a simple method here, this method, but I'll explain one more method, that is using KVL. Okay, copied, 2.5 volt is answer. Okay, now listen to me. I think all of you copied this. Yeah. Now listen to the other alternative method. Same problem I am talking about. Two cells of EMF, circuit connections are same as I have already drawn. This is a cell of EMF 2 volt and its internal resistance was 1 ohm. And here I'm having a cell of EMF 4 volt and internal resistance is 2 ohm, and they are connected in parallel so that they are sending the current through a 10 ohm resistor in the same direction. I will include a resistor here. It will be easy for you to include a resistor here if you are using a KVL. I don't mind to name this as A, this as B, this as C, and this as D, this as E, and this as F, and this is given as a 10 ohm. Using KVL, understanding. So first of all, when you are using KVL, first of all you should decide how many branches are there. I already explained you. How many branches are here? 3. One is B, C, D, A. One more is D, E, F, A. One more is A, B. So 3 branches are there, means obviously we expect a 3 current. Here I will take the current as I1. Here I will take the current as I2. I think you're listening. Here I will take the current as I3 in 3 different branches. Next question is, what is the direction of the current? You know the direction of the current can be selected arbitrarily. I1 can be directed from B to C, C to D, D to A. I2 can be directed from B to E, E to F, F to A. Or I1 can be directed from A to D, D to C, C to B. And I2 can be directed from A to F, F to E, E to B. Arbitrary direction can be selected. Even I3 can be also directed from A to B or B to A. The rule is that you can select the direction of the current arbitrarily. But I gave a suggestion when I was giving this explanation. I gave one suggestion. So even though you can select the direction of the current arbitrarily, if there is a cell in the branch, try to select the direction of the current as sent by the cell. So cell always sends a current from where? Positive to negative, correct? Positive to negative. So shall I say that current direction is in this direction? This is the direction of the current, this is the direction of I1, this is I1. Similarly, here also the cell is there, so that means I'll take the current direction is in this manner, E to F, here B to E, correct? Here F to A, I to only. And here there is no cell, no, so you can select your own direction. Shall I mark the direction of a current as I3 in this direction? Fine, A to B. Now, if you apply KCL, apply what? KCL to a node A, sum of the current entering the node is equal to sum of the current leaving the node. Which are the current entering the node? I1 and I2 are entering the node, I3 is leaving the node. I1 plus I2 should be equal to I3. Now you apply KVL. To a mesh A, B, C, D, A. See, this is the direction of a traverse I selected. A, B, C, D, A. So if you apply KVL to a mesh A, B, C, D, A, you're moving from A to B first. You know the rule. Algebraic sum of the product of current in the resistance and EMF in the mesh is equal to 0, right? So when you move from A to B, what is the resistance you come across? 10 ohm. What is the current through it? I3. So it is supposed to be 10 into I3, correct? 10 into I3 plus 10 into I3 or minus 10 into I3. It is minus because direction of a current is also from A to B, direction of a traverse is also A to B. That time product of IR is taken as negative. Move from B to C. When you move from B to C, do you have any resistance? No. When you move from C to D, do you meet any resistance? Yes. 1 ohm internal resistance you will come across, correct? 1 ohm internal resistance you come across. What is the current through it? I1. What is the resistance? 1. So it is I1 is I1 only, correct? 1 I1 is I1 only. So what is plus I1 or minus I1? It is plus I1 or minus I1? It is a minus I1 because current is from C to D, direction of a traverse is also from C to D. So it is minus I1. Proceed further. I reach D. From D to A if you move, do you have any resistance? No. So that product of IR is over in that mesh A, B, C, D, A. Now go to the EMF. Do you have EMF when you move from A to B? No. B to C? No. C to D? Yes. When you are moving from C to D, you are moving from lower potential to higher potential means EMF will be taken as positive. Plus 2 is equal to what? 0. So now this 10 I3 can be written as I1 plus I2, that is again minus I1 plus 2 is equal to 0, correct? Which implies if I simplify, don't you think I will get it as 11 I1 plus 10 is equal to 2. Okay, now next step, of course you find the previous method is the easiest one, but you should know this method also. You are going to apply KVL to a mesh. One more mesh I'll select, A, B, E, F, A. Can you see that mesh? A, B, E, F, A. This is the direction of a traverse which I selected, A, B, E, F, A. Because why I'm applying for another mesh? Because I'm having two unknowns here. I1 and I2 both are unknown. To find out I3, why I need to find out I3? Because we will be given as I3 into 10 ohm, right? I into R. What is the current through 10 ohm? I3. Resistance 10 ohm, but I don't know I3. To find out I3, I should know I1 and I2. One equation, two unknowns you can't solve. That's why I have selected one more mesh. Move from A to B. Be quick. A to B. Product of current and the resistance. KVL I am applying. 10 I3 plus or minus. Minus 10 I3. A to B. Current is also from A to B. Mesh is also from A to B. B to E. What is the resistance? 0. E to F. What is the resistance? 2 ohm. 2 into. What is the current? I2. Current in that branch is I2. No. 2 into I2. Plus 2 into I2 or minus 2 into I2. It is minus because direction of the current and direction of a traverse are same. Direction of a current is also from E to F. Direction of a traverse is also from E to F. Clear? Move from F to A. You don't have a product of IR. 0. I resistance is 0. Correct? Yeah. Now move from FTA is over. I think product of IR is over. Next comes EMF. How many EMFs are there in the mesh which I selected? Only one, 4. Plus 4 or minus 4. When you are moving along the direction of traverse, A to B, B to E, E to F, I have to move like this. No. Lower to higher potential means EMF should be taken as positive. Plus 4 is equal to 0. Again I have to substitute for I3 as I1 plus I2 according to the KCL, right? Minus 2I2 plus 4 is equal to 0. I think you understood. This will become, if I am not wrong, it will be, I think 10I1 minus 10I1 I wait. I'll simplify. 10I1 is equal to 4. Actually minus 10I1 minus 10I2 plus 4. I take the 4 others will become minus. You're sure? This is equation number 2. Now you have to solve equation 1 and 2. You have to solve equation 1 and 2. What I have to do is, equation 1 you multiplied by 10, then minus equation 2 multiplied by 11. Equation 1 multiplied by 10, equation 2 multiplied by 11. When I multiply equation 1 by 10, this will become 110I1, correct? Then this will become 100I2. Are you listening? And this will become equal to 20. 10 to the 20, no? Now I am multiplying equation 2 by 11. This will become 110I1. This will become 112 into 11 is 132, no? 132I2 will be equal to 11 into 4 is 44. I hope you followed this. I am subtracting, no? When I subtract, I have to change the sign here. This will get cancelled. This will be how much? Minus 32I2 is equal to, this will be how much? Minus 22. Or I2 is equal to 22 by 32. This is I2. I hope you understood this. We'll proceed further. Okay, I2 I got. Substitute I2 in one of the equation here. In equation 1, you will get I1. Followed? So after getting I2, I said substitute I2 in equation 1. Plus I2. Suppose if the answer is negative, you have to substitute with the negative sign only. Is it clear to you? Yeah. Once you get I3, you substitute in the formula V is equal to I3 into 10. You will get answer. Please do it. Please do it. Copy it. Copy this method. Three to 4 minutes only. Please copy it. Neatly copied, neatly copied. So actually I have to answer this. To answer this, I should know I3, that only this procedure. Finished okay. So draw the direction of traverse also. Check it later, the equations, okay. Mark I1, I2 as I already marked. Direction of a traverse you mark already. So then I'll move the page. Finished. Apply KCL to node to I3 written. Apply KCL to node A. I1 plus I2 is equal to I3. Then you're applying KVL to a mesh A, B, C, D, A to B minus 10I3, B to C minus 1I1, C to D, sorry, B to C no, C to D minus 10 minus 1I1, and D to A there is no product of IR. And 10 minus 10 into I1 plus I2 minus I1 plus 2 is equal to 0. Then 11I1 plus 10I2 is equal to 2. When you simplify it, you will get this equation. You can cross check later. Up till equation 1 over, fine. Yeah. Plus 4 is equal to 0. Apply KVL to a mesh A, B, E, F, A. Minus 10I3 minus 2I2 plus 4 is equal to 0. Minus 10 inside the bracket I1 plus I2 minus 2I2 plus 4 is equal to 0. Then 10I1 plus 12I2 is equal to 4, that is equation 2. Then solving 1 and 2, how we are solving it? Equation 1 multiplied by 10, equation 2 multiplied by 11. Copy it. Equation 1 multiplied by 10, equation 1 multiplied by 10 minus equation 2 multiplied by 11. Yeah, finish it fast. Finished. So this answer is 0.6875. You can cross check. This answer is 0.6875, that is I2. Copied up to here, right? Next, you are asked to substitute I2 in equation 1. We get I1, I said. How to substitute in equation 1? See, equation so I have to substitute for I2, 11I1 plus 10 into I2 is 0.6875 is equal to 2, or 11I1 plus, if I am not wrong, 6 multiply by 10, no, 6.875 is equal to 2. Surely 11I will get negative answer. 11I1 is equal to, this is 2 minus 6.875, correct? Do the subtraction and solve for I1. Copy it. Check it. So I1 will be equal to 2 minus 6.875 by 11. You will find that I1 is equal to, surely answer is negative because 2 minus 6.875 is obviously negative answer, no? Minus 0.55, 625. Minus 0.55, 625 is a minus answer. I think you are able to follow. Please copy it quickly. Check the answer. It is 2 minus 6.875 divided by 11. Check the answer. Will I go? I will answer is wrong. Point correct. 4431. minus 0.4431 or 32, I can take round figure. So I3 will be equal to I1 plus I2. I think you're listening. So I1 is 0.68, I1 is surely minus 0.4432 plus I2 is 6.875. You'll get I3 nearly 0.25, 6.875 plus minus 0.4432. Sorry, it's not 6 point, it is 0.6, right? It is 0.6875. Please don't make a mistake. 0.6875 minus 0.4. Then V is equal to I3 into 10. Surely I3 is 0.244 into 10. That is nothing but 2.44, nearly 2.5 volt. This is okay. This difference is okay. Copied? Yeah. So you can complete. So earlier I got 2.5 in that. So here there is a small difference I may get because of the digits which I consider at the end. Cross check the answer once if you want. Is it over? Copied? Fine. So this is 2.44 volt. V is equal to I3 into 10, 2.44 volt, nearly 2.5 volt. This is I3, I got I1 plus. Remember one thing, in this method, if the current is negative, you have to substitute a negative answer here. What is the significance of negative current? Indicating that direction of a current in the branch is not as what we have selected, it is opposite. Don't go to change the direction. Negative current indicates that direction of a current in the branch is opposite to what we have indicated. But here as negative sign only you substitute. That is an important thing to be noted. I think you followed? Okay. We'll move on to the next problem. Okay, next problem. One more similar type using KVL. Here there is no option, you have to solve using 2 ohm respectively. Have their positive terminals connected by a wire of resistance 10 ohm and their negative terminals are connected by a wire of resistance 4 ohm. Another coil of 10 ohm is connected between the midpoint of these wires. Find the potential difference across 10 ohm coil. So I will just explain the problem. You're going to complete it because this problem is same as the previous one using KVL and KCL. And here there is a one more cell. According to the 2 cells are there. This cell of EMF 2 volt and its internal resistance is 1 ohm. Correct. And another cell is of EMF 1 volt and its internal resistance is 2 ohm. What they said in the problem is their positive terminals of the cells are connected by a wire of resistance 10 ohm, totally 10 ohm. This is connected negative this by a wire of resistance 4 ohm. And their midpoints, midpoint of this wire and midpoint of this wire is connected by a one more wire of resistance 10 ohm. Positive terminals are connected by a wire of resistance 10 ohm. Negative terminals of the 2 cells are connected by a wire of resistance 4 ohm. And their midpoints, I will name the midpoint here as A, midpoint here as B, are connected by one more wire of resistance 10 ohm. Don't you think that for a simplicity, replace this A by a single resistor of resistance 10 ohm? Correct? And it is a midpoint. Don't you think I can equally divide 10 ohm as 5 ohm here and 5 ohm other side? Here 5 ohm and here 5 ohm. 5 plus 5, how much? 10. This is a totally of how much resistance? 4 ohm, right? 4 ohm and this is a midpoint. No. So can I here I have a 2 ohm and here the resistance of this wire, let it be 2 ohm. 2 ohm plus what? 2 ohm will be equal to 4 ohm. See. Now I'll name this point for our reference as C, this as D, this as E, this as F. Means point to be noted is here I am having some additional resistance. It was not there in the previous problem. Here I am having a 2 ohm. Here I am having 5 ohm. Here I am having 5 ohm. Here I am having 2 ohm. There is a difference. Now you are asked to find out a potential difference across 10 ohm. For that I should know resistance and a current. Resistance is there but current we don't know. Can you please tell me first step. How many branches are there? 3. B, C, D, A, B, E, F, A and A, B. That means I can expect 3 branch currents, right? Shall I take I1 here and I2 here and I3 here? 3 branch current. Current in the branch B, C, D, A should be same, I1 only. Current in the branch B, E, F, A should be same, I2 only. Correct? Current in the branch A, B should be same, I3 only. Next question is, what is the directions? Directions of I1, I2 and I3. I told you can select direction of a current arbitrarily, your choice. But of course, you don't have more choice. You have only 2 options. Either the one you have to select. No matter if the direction of a current is opposite to actual current, when you do the calculation, you will get a current as a negative. That is what we found in the previous problem, correct? But I gave one suggestion. If there is a cell in the branch, try to send a current as indicated by the cell only. Cell always sends a current from positive to negative. I am talking about conventional current. That means I1 should be in this direction. So in the branch is the same, means obviously current should be same direction. No, here I1 only. Here also I1. Here also I1 only. I hope you followed this. Look at the second branch I2. Can I select the direction of a current as sent by this cell? I2. This is I2. This is I2. I hope you followed this. This is I2. I think you understood. What about the current here? I3. Your choice. No, there is no cell. No. Shall I select direction of a current in this direction? A to B. Fine. Over. Now, if you try to answer the question, obviously potential difference across the 10 ohm resistor should be equal to I3 into 10 ohm. No. It is I3 into 10 ohm. Now tell me, what is missing? To find out I3, I have to go for the same procedure which I followed in the previous problem. First, KCL. Apply KCL to a node. Shall I take up a node as A? Yeah, if I apply KCL to a node A, it should be I1 plus I2, current entering the node, is equal to I3, current leaving the node. That means to find out I3, of course to find out B, I should know I3. To find out I3, I should know I1 and I2. Correct? Okay, now the question is how to find out I1 and I2. You have to apply KVL. Apply KVL to a mesh. Will you try to name the mesh? Yeah. A, B, C, D, A. When you apply A, B, C, D, A, say I will apply and write the equation. Simplification you have to do. A to B. A to B. What is the resistance? 10 ohm. What is the current? I3. So this is the direction of a traverse. No, I will mark the direction of a traverse. Is it in this direction? A, B, C, D, A. Sorry. A, B, C, D, A. A, B, C, D is the direction of a traverse. A to B. What is the resistance? 10. What is the current? I3. Correct? So it should be plus 10 I3 or minus 10 I3. It is minus 10 I3. Direction of a current and direction of a traverse are same, means product of IR is negative. No. Move from B to C. B to C, when you move, do you have any resistance? Exactly. Now you have a 2 ohm resistance. Earlier problem it was not there. 2 into I1. Plus 2 into I1 or minus 2 into I1? Minus, because direction of a current and direction of a traverse are same. Direction of a traverse is B to C. Direction of a current is also same. So product is negative. Move from C to D. Whom you meet? Internal resistance of 1 ohm. Correct? 1 ohm into I1. That is a minus I1. Why minus? Direction of a traverse is C to B. What is the current? I1. So plus 5I1 or minus 5I1? Surely minus 5I1, because direction of a current and direction of a traverse are same. So algebraic sum of product of IR is over. Now coming back to the algebraic sum of EMF. When you go along the direction of traverse A, B, C, D, A, when I am crossing the cell, I am moving from lower to higher potential, means EMF will be taken as positive. No, that is equal to 0. Understood? Okay. This I3 can be replaced as you know that I1 plus I2. I have written the first equation applying KCL. So the remaining thing is this is 2, 3 and correct, no? 2, 3 and 5, 5, 6, 7, 8. 8 I1 plus 2 is equal to 0. If I simplify, simple mathematics, it is, yeah, what do you get? 18 I1, 10 I2 is equal to 2. 18 I1, 10 I2 is equal to 2. I said 18 I1, 10I2 is equal to 2. Equation 1. Then you apply what? How many unknowns are there? 2 unknowns. One equation. You can't solve, no. Apply KVL to a mesh. Apply KVL to a mesh. One more mesh I will select. A, B, E, F, A. A, B, E, F, A. Be quick. I'm not going to complete the problem. It will be homework for you. I'll just write the equation and keep it with you. A to B. Tell me, when you're moving from A to B, what is the resistance you meet? 10. What is the current I3? Plus 10 I3 or minus 10 I3? It is minus, because direction of a current is from A to B. Direction of a traverse is also from A to B. Then move from B to E. B to E, diometer and resistance 2 ohm. What is the current I2? So 2 I2 plus 2 I2 or minus 2 I2? Obviously minus 2 I2, because direction of a current and direction of a traverse are same. Okay, next E to F. Whom do you meet? 2 ohm. What is the current? I2. 2 I2 plus I2 or minus? Direction of a current and direction traverse are same. F to A, diometer and resistance exactly 5 ohm. That is minus 5 I2 is equal plus. When you're moving from equal to 0, I think you understood. This I3 can be written as I1 plus I2. This is 2, 4, 9 I2 plus 1 is equal to 0, correct? And when you simplify this, I'm surely you'll get 10 I1 plus 19 I2 is equal to 1. You can cross check. Simple mathematics, no physics behind that. And the remaining things I'll leave it to you. You have to solve for I1 and I2, then you have to substitute in you get I3, then substitute here. You have to complete this. Copy this problem. You understood what I said? Remaining things you have to do. First copy this problem. Then remaining things is using 1 and 2. Solve the simultaneous equation 1 and 2. Solve for I1 and I2. Substitute I1 and I2 back in this problem formula. You'll get I3. Substitute I3, you'll get V. Copy it as it is. You'll not get more than again 3 to 4 minutes. Copy it fast. Copy the circuit diagram. So after this, only one 5 marks numerical is left out, okay? After this, only one 5 mark numerical is left out. Copy it fast. Applying KCL to a node, I1 plus I2 is equal to I3. Applying KVL to a mesh, A, B, C, D, A. Minus 10 I3, minus 2 I1, minus I1, minus 5 I1 plus 2 is equal to 0. So then when you simplify it, cross check later, 18 I1 plus 10 I2 is equal to 2, equation 1. Then applying KVL to a mesh, A, B, E, F, A, minus 10 I3, minus 2 I2, minus 2 I2, minus 5 I2 plus 1 is equal to 0. So this is minus 10 into I1 plus I2, minus 9 I2 plus I1 is equal to 0. Then when you simplify it, you will get the equation as 10 I1 plus 19 I2 is equal to 1. Over. I said it is a homework, remaining things is homework. You have to complete. What you are supposed to do, I said you have to solve equation 1 and 2 for I1 and I2. Using 1 and 2, solve for I1 and I2. So I'll tell the answers in the next session. Okay, so now you take up again AIC level 1. Few minutes are left out. I will complete at least one. If I go for the next problem, it takes a long time. AIC level 1 problem. AIC level 1. All of you take out AIC level 1 problems. AIC level 1. Problem number 5 I will solve. It's over now? Yeah. Problem number 5 I will solve. Okay, yeah, look at this problem. A metal cube of edge 1 centimeter, means there is a metal cube in the problem whose side is 1 centimeter, is drawn into a uniform wire. It was drawn, means using this metal cube, it was drawn into a uniform wire of length 2 meter. This metal cube is drawn into form a uniform wire of length 2 meter. Uniform wire means throughout the length thickness is same. So one thing is clear that according to this, volume of the cube should be equal to volume of the wire. Correct? So volume of the cube means obviously side cube is equal to volume of the wire means area of cross section into length. Yes or no? So what is the side of the cube they are given? Side of the cube is 1 centimeter means 1 in 10 to the power minus 2 the whole cube is equal to A into L, correct? Or which implies A into L is equal to 10 to the power minus 6 meter cube. Keep in mind. Now this wire, they said cut into 3 pieces of equal length, then joined to form a triangle. That wire cut into 3 pieces of equal length, then joined to form a triangle. Find the effective resistance between any 2 vertices. Shall I name the vertices as A and B for our reference? If I say that resistance of the original wire is R, what is the resistance of each piece here? Obviously, I will take it as R dash. All are R dash only, but R dash is equal to R by 3, correct? I think you are able to follow what I said. Resistance of the single R dash is supposed to be R by 3 because the single wire is cut into 3 pieces of equal length. When they are of equal length, surely the resistance of each piece is same, no? Now you are asked to find out effective resistance between A and B, any 2 vertices. How these two are connected? Series. I can replace it by a resistor of 2R dash, R dash plus R dash. How that 2R dash is connected to R dash in parallel, correct? Between A and B. How to find out effective resistance? Parallel. RP formula. You understood, no? R dash and R dash are in series, 2R dash. And the 2R dash is connected in parallel with R dash. So it will become 2R dash into R dash by 2R dash plus R dash. Surely RP will be equal to, that is the final resistance, 2r dash the whole square by 3r dash, which is equal to 2r dash by 3. Now I have to find out r dash. To find out r dash, I should know r. How to find out r? R is given by the formula rho L by A, correct? So again the problem is, rho is not a problem, it is given at the end of the problem. A can square by 10 to the power minus 6, which implies r is equal to rho is how much? It is given as 0.3 into 10 to the power minus 6. L is 2 the whole square divided by 10 to the power minus 6. Can I cancel 10 to the power minus 6? 2 square is 4. 4 into 0.3 is obviously 1.2 ohm. R is 1.3 ohm, 2 ohm, which means R dash is 1.2 by 3 is equal to how much? 0.4 ohm. Substitute there, no? Yeah. It is how much? R dash is 0.4, no? R dash is 0.4 ohm. 2 into 0.4 by 3. So what is the answer you get? 0.8 by 3, correct? 0.8 by 3 is nothing but, if you multiply by 5, it will be, if I am not wrong, 4 by 15 ohm. Check the answer. Followed? Yeah. Copy this solution as it is. First, there is a cube of side 1 centimeter drawn in the form of a uniform wire. Let us say its resistance is R. Its length was given as 2 meter. One thing you should highlight, that volume of the cube will be equal to volume of the wire. So it is how it is 4 by, okay, it is volume of the cube is equal to volume of the wire. Volume of the cube is side cube is equal to A into L, or area of the volume of the wire is the area of cross section length. 1 into 10 to the power minus 2 the whole cube is A into L, that which means A into L is equal to 10 to the power minus 6 meter square, or A is equal to 10 to the power minus 6 by L. Then it was given that this wire is cut into 3 pieces of equal length. So resistance of each piece is R dash, which is nothing but R by 3, 1/3 of the original resistance. R dash and R dash are in series. Its resistance is 2R dash. Now the 2R dash is connected in parallel with R dash. So you got RP as, this is the solution, 2R dash by 3. Problem is R dash. R dash is R by 3. So how to calculate R first? Rho L by A. Rho L by A is 10 to the power minus 6 by A. You can refer this. L will go to the numerator. Rho L square by 10 to the power minus 6. I substitute here 0.3 into 10 to the power minus 6 into 2 square by 10 to the power minus 6 will get cancelled. We'll get 1.2. If R is 1.2 ohm, since R dash is R by 3, R is 1 by R dash is R by 3, 0.4. When I substitute here, 2 into 0.4 by 3 is 0.8 by 3. It is 4, out of the given option, it is 4 by 15, just because, yeah, you can just multiply both numerator and denominator by 5. 0.8 into 5 is 4. 3 into 5 is 15. 5, 5. That is what I did. Or you simplify the options, you will get the answer. 4 by 15. 4 by 15, if I divide 5 3s are 5.8. 5 3s are 15, 5.8. So this is the answer. 4 by 0.8 by 3 ohm, 4 by 15. Clear? Yeah. Complete the problem. Complete the problem. Copied. Copied. This is an AIC level 1. Question number 5. Copied. So original resistance was R. It is divided into 3 equal parts and forming a triangle. You are asked to find out effective resistance across any 2 vertices. This is a battery. R dash are in series, 2R dash. The 2R dash is in parallel with R dash. RP is 2R dash into R dash by 2R dash plus R dash. Or you can directly calculate 0.8 into 0.4 by 0.8 plus 0.4. I said no, you can. I said no, you have other method. Once you get r dash, directly you can go for this. This is a 0.8, this is 0.4. So 0.8 into 0.4 by 0.8 plus 0.4. That is also fine. This is 0.32 divided by, this is 0.8 plus 0.1. This is 32 by 120. This is nothing but again 4 by 15. Understood now? Okay. So option is B, 4 by 5 ohm. Got it? Yeah, we'll continue the next session. And please complete that problem which I gave you. Please complete that problem. We'll continue the next session. Thank you.